In this video, we are going to configure single arrow OSPF. OSPF is a link state routing protocol described in RFC 2328. There are two versions of OSPF. OSPF version 2 is for IPv4 and OSPF version 3 is for IPv6. OSPF will use Dijkstra shortest path first algorithm to calculate the best path. The best path calculation is based on the cost, so OSPF use cost to calculate the metric. And OSPF is link state routing protocol. All routers configured for OSPF will maintain complete network topology. To minimize the processing and memory requirement, OSPF can divide the routing topology into two-layer hierarchy. So we can configure single arrow OSPF, only use the backbone arrow, so we have arrow 0, or we can configure multiple arrow OSPF for large network. Then we set up the backbone arrow and a non-backbone arrow. For all non-backbone arrow, it must connect to the backbone arrow. So OSPF support a lot of features, and OSPF can achieve fast convergence, and it support VLSM and support manual routing summarization, route summarization. So I prepared topology. Let's look at how we can configure OSPF in this network. We look at the topology on the left first. I have three routers. All routers are configured with an interface IP address, both for IPv4 and IP version 6. So when we use the show run, we can see the router configured with IPv4 and IP version 6 address. In this video, we only look at how to configure OSPF version 4 for we only look at how to configure OSPF version 2 for IP version 4. And on the topology, I marked with a loopback interface IP address, but the router haven't been configured with a loopback interface IP address, and we'll configure it later on. But all the physical interface already be configured with an IP address. We can use the show IP route to check the current routing table. Router only node is a directly connected network. So on R1, I have network 192.168.1.0 for the gigabit interface. On R2, and I configure its gigabit interface with a IP address or IP interface brief, and it's 209.165.200.225. I use this interface to simulate the connection to internet. So I will set up a server which has an IP address 209.165.200.226. Later on, we will test the network connectivity to this IP address on the internet. And the same thing for R3. R3 only have the interface be configured with IP address. So show IP interface brief. We can see the interface IP address, and R3 gigabits is 192.168.3.1. Now at the moment, if I ping from PCA to PCC, my ping will fail. So ping 192.168.3.3. We receive a message say destination host unreachable, because if we look at router 1's routing table, its only node is a directly connected network, has no idea for the remote network. So the network connect to R3 is a remote network for R1. Now let's configure OSPF. On R1, we configure router OSPF. Now we should give the process ID. The process ID is start from 1, can up to 65535. for the router to form neighbor adjacency and share routing information with each other, the process ID doesn't have to be the same. But in our configuration, we just configure process ID 1. Then we'll use a network statement to advertise the network. So for R1, we have the gigabits G00 connect to network 192.168.1.0. 8 has a subnet mask or prefix /24. So for /24, the subnet mask is 255.255.255.0. Then we need to calculate the welcome mask. The welcome mask is a reverse of subnet mask. So we will have 255.255.255.255 minus the subnet mask. Then the reverse mask is going to be 255 and with error 0 because we only configure single error and configure single error OSPF. We'll use error 0. Then I advertise the serial interface 10.1.1.0 with 0.0.0. Welcome mask is 3 because the prefix /30, the subnet mask is 255.255.252. So the welcome mask is 0.0.0.3 and the error 0. Then that is a connection between router 1 and router 2. We need to advertise the network between router 1 and router 3. So we change it to 3.3. Now let's check show IP protocol. We can see on R1, we configure the OSPF process 1 and the router will select the router ID. So there's a certain selection criteria for a router ID selection. At the moment, the router only be configured with a physical interface IP address. So the highest physical interface IP address is going to be the router ID. So gigabit interface IP address is higher than serial interface IP address, and that is a router's router ID. The router ID is used to uniquely identify each router for OSPF. We configure the 3 network statement. That is, the router is going to advertise this 3 network to its neighbor router. So that is configuration on router 1. On router 2, we are going to do the same. Router OSPF1, we advertise 10.1.1.0, 0.0.0.3 with the error 0. Then the next one 10.2.2.0, 0.0.0.3 with error 0. Now, while we are configure R2, we receive a message say R2 form neighbor adjacency with R1. So that is R1's router ID through the serial interface is form full neighbor adjacency. So when router configured for OSPF, it will pass through couple states and eventually router will form the neighbor adjacency and we call it as a full neighbor adjacency. Means the 2 routers they have identical link state database. Now we are going to do show IP OSPF neighbor to check its neighbor adjacency. So R2 form neighbor adjacency with R1. It is a full neighbor adjacency. When I say full neighbor adjacency, means the router they are going to maintain same link state database or the same network topology. So we can use the show IP OSPF neighbor and to check show IP OSPF database to check which network be advertised by OSPF. So this is the type 1 LSA. Each router configured for OSPF will send out the type 1 LSA. We can see it in the link state database. And through which interface R2 form neighbor adjacency through interface at 001. And this is a timer for OSPF. So OSPF will send hello packet to each other to form the neighbor GCC. So the hello packet is used for network topology discovery, and also when there's a topology change, if router couldn't receive hello packet, it will remove the neighbor from the neighbor table. So the connection between these two routers, they are point-to-point connection. So the network type, we can use the show IP OSPF interface to check the network type. OSPF support different type of network, so the network is a point-to-point. So for the point-to-point connection, and they form the full neighbor GCC. For the interface priority for the point-to-point connection, that is a 0. So the priority for the interface by default is a 0. Hello packet was sent out every 10 seconds by default on point-to-point network, and the died interval is a 4 times of hello interval. So every 10 seconds, router expects to receive hello packet from its neighbor. If in 40 seconds the router still didn't receive the neighbor GCC from still didn't receive hello packet from its neighbor, router will consider the neighbor is down, remove the neighbor from its neighbor table, also remove all network and learn from its neighbor in its routing table, will remove it out. Now on R2, you may notice I haven't advertised the gigabit interface. I will leave it for further configuration. I go to R3. On R3, I will configure OSPF in different way. So I go to interface at 000, and I do IP OSPF1 arrow 0. So this time I didn't use a network statement. I go to the interface configuration mode. I enable OSPF for that interface. Then you see I receive message says a phone neighbor GCC. I'm going to do the same one for the serial interface, and then later on I should see two neighbors, and my neighbor will be with R1 and R2. So we do show IP OSPF neighbor. Now R3 form neighbor GCC with R1, form neighbor GCC with R2. On R3, I also want to advertise my gigabit network to OSPF. So we do show IP OSPF1 arrow 0. Now let's check the routing table. What we have on R3 now, it has its directly connected network identified by C, and its link local address that identified by L, and also we can see O means OSPF, so the network actually learns through OSPF. We can use a show IP route. We just check the network learned by OSPF, so OSPF. Now R3 now knows how to reach network attached to R1 through the best path is through its serial interface. The metric is a 65. So how OSPF will calculate the metric? OSPF metric is based on the cost. So OSPF maintain an auto cost reference bandwidth, and then it divided by the interface bandwidth. That is a cost value. So if we have fast internet or any bandwidth faster higher than 100 megabits per second, the cost is a 1. For T1 link, the T1 link has a bandwidth 1.44 megabits per second. The cost is a 64. So for OSPF, the cost actually is the sum of the interface cost. So from R3 to reach network attached to R1, the serial interface that cost is a 64. For the gigabit interface, the default cost is 1. So 64 plus 1, that in total is a 65. So it is the sum of the interface cost, and that is a metric. So we can see it in the routing table. for the network to attach to 10.1.1.0, R3 will maintain two paths because these two paths, they all have the same cost. So for the serial interface from R2 to from R3 to from R3 to R2, so cost is 64 plus another 64, 128 through the bottom link, still 128. So both paths through interface at 00 and at 001, they have the same cost. Then router will install both of them in its routing table to load balancing. Okay, then we can check the cost by using the show IP OSPF interface. So we'll see all the interface configured for OSPF. For the serial interface, the cost is 64. How we get the cost? And it relies on the interface bandwidth. And so we have reference bandwidth divided by interface bandwidth. Then we got the cost value. For the gigabit interface, so the gigabit interface is 1. So to reach the network from R3 to R1, the best path is through the bottom link. Now, all router should receive the routing update from my neighbors, and they know all the network, how to reach the remote network if we do the show IP route OSPF. So R1 knows how to reach R3 network. So let's go back to the ping. We see this time we can ping from PCA to PCC or not. The first packet get lost because of the ARP request, and the following packet all get replied. So if we ping again, so now PCA is able to reach PCC because router can find out the path in the routing table to reach the remote network. So far, we did look at how to configure single error for OSPF version 2 for IP version 4. Now, the next thing, I want to modify the cost. So for R1 to reach R3 network, the cost is 64. Now, I have two ways to modify the cost value. So for R1, and I can go to the interface. So interface at 001 that attach the at 001 will reach to connect to R3. I can configure the bandwidth instead to have default bandwidth. So for the serial interface, the default cost, the default bandwidth is 1.44 megabits per second. The cost is 64. Now I'm going to change the interface bandwidth to 128 kilobits per second. So I go back to my router 1 and I do 128. Now we did change the interface bandwidth. Let's do the show IP route OSPF again. So now we see the cost value change. Why this cost value change? If I do the show IP OSPF interface, we look at the serial interface, or the serial interface here, my serial interface at 001, because we changed the at 001 bandwidth. So now the cost become 781. So for 128 kilobits per second, after calculation, the cost is 781. Now check the routing table this time. And for R1 to reach network connect to R2 and R3, also the network connect to R3, the best path all through is a serial interface. Why this is happen? If we look at the topology, so now before R1 use the bottom link to reach R3 gigabits interface, load balancing between R2 and R3 to reach 10.2.2.0 network. Now, after we change the interface bandwidth, R3 decide to use the top path to use the connection between R2 to R3 to reach the destination. Because now the bottom link, the cost is 781 plus 1, it's going to be 782. So that is a very big value. but through the top link is 64 plus 64, so that is always is a better path. So the metric and through the top link is 128 to go to 10.2.2.0, and for the bottom path and the cost is 129. So 64 plus 64 plus 1, the cost is 129, and R1 decides the best path is through R2 to reach the other network. So that is one way we can change. We can manipulate the cost selection. We change the interface bandwidth. So this bandwidth is not real bandwidth for the interface, just for OSPF to calculate the best path and to decide which path will offer to the routing table. Okay. Now let's do it another way, and I go back to the interface at 001 and no bandwidth. Remove the bandwidth command. Remove the bandwidth. We configure show IP route OSPF again, and now we restore the routing table like it's the original one, so we can see the cost value. Now, the next thing I want to do is to change the auto cost reference bandwidth. The reference bandwidth by default is 10 to the power of 8. So when we have fast internet, the cost is going to be 1. So even we have gigabit interface, the cost is still 1. This cost doesn't really reflect the actual interface bandwidth and the actual cost calculation. So we can change the reference bandwidth. So on R1, now I'm going to do all router. So we need to go to router OSPF1 auto cost reference bandwidth. So the default is 1 for 100 megabits per second. Now I change it to 1000 megabits per second. Now I did it on R1, receive message. When we change the reference bandwidth, we should do it on all routers to maintain the consistency. So on R2, I do configure T router OSPF1 reference, auto cost reference bandwidth, change it to 1000. So on R3, we do the same. Now go back to check R1's routing table after we change auto cost reference bandwidth. So show IP route OSPF. Now you see the value change. So before, when we have 100 divided by the gigabits, that value is going to be 1. Now we have 10 fast internet is 100 megabits per second. Now we change it to gigabits per second. So the gigabits per second divided by the serial interface bandwidth and plus a gigabit bandwidth. So the new cost is changed. So we did change the reference bandwidth and to make it reflect the gigabits cost. So if I go to the gigabits and show IP OSPF interface, and we can see for the serial interface, the cost value is changed. Also for the gigabits interface, the cost is 10 because even the interface is gigabits interface and the PC still fast interface. So after negotiation, the bandwidth is going to be 100 megabits per second. Then the new cost is 10. So we did the calculation. Now, the next thing I want to do is to modify the router ID. So we did look at how to configure OSPF, how to modify the cost, and I want to look at how to affect the router ID selection. So on R3, if I do the show IP protocols, and the R3 router ID is 192.168.3.1, that is the highest interface physical interface bandwidth. Now on R3, I'm going to configure an interface. So we call it interface loopback 0, and we give IP address 192.168.30.1, 255, 255, 255.0. Okay, now after the router configure with a configure for OSPF, router ID already be configured, router ID already be selected, and if we configure the loopback interface IP address, we want it as a router ID. What we can do, we have copy run to start, and we reload the router. So after we reload the router, we check what is router ID. So before router on router 3, its router ID is 192.168.3.1, where we can see it. Okay. Now let's do show IP protocol. We check the new router ID. So you see the router's router ID it changed to 30.1. Not like before when we do the show IP OSPF neighbor and we check the other router ID. Where is it? I don't have that command anyway. So I just look at router 1's router ID. It pick up the new router ID. Now another way to change router ID is in the router. We configure with a router ID command. So router ID, and for router 3, if I do 3.3.3, now after we configure the router ID, we should restart OSPF process. Otherwise, the new router ID is not going to take the router ID is not going to be used. So now, all right, it just rebuilt the OSPF. So to clear IP OSPF process, we do clear IP OSPF process, and we do yes, and force the router to reselect the router ID. Now on R1, if I do show IP OSPF neighbor, we can see router 3's router ID becomes 3.3.3.3. So when the router be configured with router ID command, it also has a loopback IP address. All physical interface configured with IP address, the router will use router ID, whatever be configured as a router ID. If the router didn't be configured with router ID, the router will use a loopback interface IP address as its router ID. No loopback interface is going to use a high physical interface IP address. Okay, now I do the same for R1. So config T router OSPF1 router ID 1.1.1. And now we receive a message say we need to reload or use a clear IP OSPF process for this to take effect. So now clear IP OSPF process, and we answer yes, and force the router to reselect the router ID. So on R2, so we do the same, router OSPF1 router ID 2.2.2. Now clear IP OSPF process. I just give enter, didn't answer yes. So now all router is going to have a new router ID. So they form the full neighbor adjacency OSPF neighbor. So we can see router identifies neighbor by the new router ID. Now that is how we can change the router ID. Say the router ID be elected as soon as the router be configured for OSPF. If you want to change it, you have to ask the router restart the router OSPF process. The next thing I want to do is configure passive interface. So we look at the router configuration. Within the router 1, I can just check the OSPF configuration. I do section OSPF. So router configure to advertise these 3 networks. So the network statement has a 2 functions. The first function is to tell your neighbor you can reach this network through you. They can reach this network. The second thing will enable the interface which configure for the network statement to send and receive routing update. So the routing update will send out the serial interface 00, 001 and also send out your gigabit interface. But if we look at the topology, there's no any other router connect to gigabit G00. So we send out the OSPF update out of this interface. It just weighs the interface band, just weighs the bandwidth. So what we can do, router OSPF1 passive interface. We set up the gigabit interface as a passive. So when we configure interface as passive, no update will send out of this interface, no update will receive on this interface. Because the gigabit interface, there's really no need to configure no need to send out the update. There's no any other router connect to it. So that is one way to configure passive interface. On R3, if we look at the show IP interface brief, now we have 4 interface gigabits and we have serial interface. Also, we get the loopback interface. So to configure passive interface, we should set up the gigabit interface as passive, the loopback interface as passive. Now, I'm going to do another way, router OSPF1. We configure with a passive interface default. So when we configure passive interface default, OSPF will put all interface as a passive. Because all interface as a passive, no update sent on the serial interface anymore. No update received on the serial interface as well. So we receive message. So the neighbor adjacency is done. So R3, and if what we do, show IP OSPF neighbor and has no neighbor, and we go to R1, we do show IP OSPF neighbor, and we can see the countdown timer because R3 is not going to send update on this interface. So router 1 expect hello packet from R1 up to 40 seconds, no update received from R3, so no update received from R3, then router 1 remove its neighbor from its neighbor table. So when we do show IP OSPF neighbor, and R1 is not neighbor with R3 anymore. Then for the serial interface, we do need to have update. So after we put all interface as a passive, we do no passive interface at 000 and no passive interface at 001. Now, OSPF update will be allowed to send out these 2 interface. They reform the neighbor adjacency. So only when you have the neighbor, you can receive update from your neighbor. So show IP OSPF neighbor, and we can show IP route. We learn from OSPF. Okay. So that about the passive interface. Now the next thing we look at default information originate. Now on R2, I have gigabit interface and I just use it to simulate the connection to the internet. And on R2, we can configure, so configure TIP route 0.0.0.0, 0.0.0.0, and anything is not local, I will send out the interface G00 and I send it to the internet. Now on R2, let's ping 209.165.200.226 on the internet. So that is an IP address on the internet. We receive reply. So that is because IP route we look at, it has a static default route configure. So anything not local and send out to this interface. But when we look at R1 and R3 routing table, when we do show IP route, it has a directly connected network. It knows the connection between R2 and R3 through OSPF. It knows the network connect R3 through OSPF. And R1 doesn't know how to reach the network on the internet. So if we do ping 209.165.200.226, and the ping will fail because that's not in the routing table. So we can do the same thing like we did it on R2, configure static default route on R1 and R3. Say anything not local, you send out the interface and to reach the internet. But we can also let R2 to propagate its default network, to share its default route with other routers, share with its neighbors. So to do it, we do router OSPF1, we do default information originate. Now, after we configure default information originate, let's look at R1's routing table again. So this time we compare with these two routing table. I do the show IP route. Now on R2, we learn the default route. So we have OSPF. We learn the star means the default route. It considered as external type 2 route. So that network we learn by OSPF. For any network is not belong to OSPF, we consider as an external network. The external network can be type 1 and type 2. When we use default information originate, by default is a type 2 external network. So its metric is 1 through its interface at 00. Now let's use the ping again. So this time we receive reply. Even the network 209.165 is not in R2's routing, it's not in R1's routing table, but we have the default route, mean everything we are able to send it out. So now we can ping the remote network. Same for R3. If we check R3's routing table, and it has a default route as well. So you can see the gateway of last resort, it be set it up. Now both R1 and R3, they learn the default route from R2 by using the default information originate. So R2 said, I have default route, I can share with you. So that is what happened. So we just configure the default route, default information originate, and on R2 to share the default route with its neighbor. Now the next thing we want to look at the hello and the died interval. For all router configured for OSPF, they need to have same hello and dead interval to form neighbor adjacency. So on R1, when we do the show IP OSPF interface, and we can see the timer, the hello interval is 10 seconds, the dead interval is 40 seconds, so by default. And on the serial interface, it's the same, so we can see the timer. Now I want to change the timer, so I go to interface at 000. I do IP OSPF hello. I change it to 5 seconds. So when we change the hello to 5 seconds, means the router will send hello every 5 seconds. And then the died interval is a 4 times hello interval, and we change it to 20 seconds. So if we do show IP OSPF interface, we just look at 00, the timer, we change it. After we change the timer, and we can check the show IP OSPF neighbor. Okay, now you see the countdown time. We change the timer on interface at 00. Now it lost the neighbor adjacency because the died interval and hello interval is different between R1 and R2. So R2 is not neighbor with R1 anymore. So for OSPF to form the neighbor adjacency, the hello and dead interval need to be same. If we change it on R1 serial interface, so on R2, I need to do the same interface at 000 IP OSPF hello and change to 5 seconds IP OSPF dead, change it to 20 seconds, then the neighbor adjacency is going to be restored. So now you see we receive message and they form the neighbor adjacency. So that is for hello and dead interval, how to change hello and dead interval. The